Lesson 1, Triangles. So we're going to go through each of these triangles and determine what they are based on these definitions. So the first kind of definitions that we have to do with the type of angles that you have. So it can either be acute, obtuse, or right. And then the next have to do with the sides. So you're always going to have two different classifications. So what I want you to do is I want you to pause this video, and on your sheet that you have printed out, I want you to measure all of the sides with a ruler in centimeters, and then I want you to measure all of the angles with a protractor. So the first thing that you should notice, this is what you should get for your numbers. Compare them. They may be off by a little bit, but it's probably just rounding. But the first thing that you should notice is that all angles add up to 180 degrees. And if yours don't perfectly, it's probably very close. So we're going to go through each of these and first determine if it's acute, obtuse, or right. So for the first one, what acute means is you have angles that are less than 90 degrees. Obtuse means you have one that is greater than 90, and right means you have a right angle, so a 90-degree angle. So if you do not see anything obtuse, anything that is bigger than 90, that means it's acute. So our first triangle is 74, 74, 32. Those are all acute. The next one is all 60, so it is acute. The next one has a 90-degree angle, so it is right. The next one has all acute angles. The next one also has all acute angles. And our last one has 113, so it is obtuse. So that's our first classification. Now we need to determine if it's equilateral, isosceles, or scalene. If it's equilateral, it's going to have all equal sides and all equal angles. So that would be this one right here. And all equilateral triangles have 60-degree angles. Isosceles has two sides and two angles that are the same. Scalene is different, all different. So our first one has two angles that are the same as well as two sides. So it is isosceles. Our next one has all different sides and all different angles, so it is scalene. Our next one also has all different sides and all different angles, so it is scalene, as well as the remaining two. Scalene is going to be pretty common. So if there's nothing that's the same, it's going to be scalene. It means it's all different. Example 2. We're going to find the missing angles in this. So first triangle, we have sides of 5 feet, 5 feet, and 5 feet, which is making this an equilateral triangle because they're all equal sides, which means that the 180 degrees in the triangle have to be split equally among the three, making every angle 60 degrees. So 60, 60, and 60. For our second angle, it is a right triangle. And we know two of the angles. So to find the remaining angle, we're going to take 180, subtract 90, and subtract 67. We're left with 23 degrees, so our remaining angle is 23. And our last one is an isosceles triangle, and I can tell because we have two sides that are the same, which means that my two remaining angles have to be equal. So what I'm going to do is I'm going to take 180 and subtract this angle to get 130. And then this 130 has to be split equally amongst the two angles. So each of these angles is going to be 65 degrees. So just be careful what type of triangle it is. It might help you determine what you're going to do. Alright, just to do some trigonometry review, we're going to do some Pythagorean theorem first. So Pythagorean theorem only works when you have a right triangle. So we're going to solve for the missing sides on the following triangles. So we have triangle ABC, and it is a right triangle with angle A being a 90-degree angle. Angle B, angle C. Recall that when you are labeling your triangle, the side across from the uppercase B will be the lowercase b, so this side would be 3, making this side 4. When you are going to solve these problems, remember that the hypotenuse is always across from the right angle, and we call the remaining sides legs. If you want to go back to using a squared plus b squared equals c squared for the Pythagorean theorem, you're more than welcome to, but just remember that it's a leg squared plus a leg squared makes the hypotenuse squared. So we're going to go h squared is equal to 4 squared plus 3 squared. So we know that h squared is equal to 16 plus 9. When I add 16 plus 9 together, I would get 25. And then we take the square root of both sides, and h is equal to 5. This is a special triangle. It's 3, 4, 5. It's called a Pythagorean triple, anytime you have 3 sides with no decimals. Okay, example 2, in triangle ABC, angle A is 90 degrees. Again, this time we know side A is 6.5, so we know the hypotenuse. And we know that side B is 4.2. So this one's a little bit different in a sense that we know the hypotenuse. It doesn't matter which leg is which. So we're going to do 6.5 squared is equal to 4.2 squared plus a leg squared. To get the leg squared by itself, we will now subtract. So it will be a subtraction instead of an addition like the last question. So you have 6.5 squared minus 4.2 squared equals L squared. Then we're going to square root both sides. So type this into your calculator. On the left side, you should get the square root of 42.25, subtract 17.64, which would be the square root of 24.61. And we type this in. It should round out to be 5.0. The next review is going to use, oh, wrong ones. Okay, here they are. It's going to use the primary trig ratios. So you should recall that that is SO, CA, TOA, with O representing our opposite side, A representing our adjacent side, and H representing our hypotenuse. So we're going to find the angles for the following triangle. We're going to pick an angle to start with. Let's pick angle G. So we're going to label all of the sides. Always start with your hypotenuse because it's across from the right angle. So this is our hypotenuse. The opposite is across from the angle, so this is O. And our adjacent side touches the angle but isn't the hypotenuse, so that's your A. So right now I have an O and an A. And looking at my ratios, the one that's going to work with is TOA. So we're going to use TOA, and when you're finding angles, you're always going to do tan to the minus 1. So you have tan to the minus 1 of O over A. So we have tan to the minus 1 of 18 over 10. Type this into your calculator. Make sure it is in degree mode. And you should get angle G is equal to 61 degrees. If we want to find the remaining angle, you would do 180 minus 90 minus 61. But I think this question said only to find angle G. Okay, for the next one we want to find both angle D and angle B. So it doesn't matter which one we start with, so let's just start with angle D. So first label the hypotenuse across from the right angle, then the opposite side, and the side we don't know is the adjacent. So we are dealing with an O and an H. If we look at our trig ratios, that is sine. So we're going to do sine to the minus 1 of O over H, which is sine to the minus 1 of 4.6 over 8.7. Type this into your calculator and you should get 32 degrees for angle D. Once we know angle D, we can find angle E by doing 180 minus 90 minus 32, and we are left with 58 degrees. Okay, our last two examples are a review of the sine law and the cosine law, and that's from our trigonometry unit. So we'll start with the sine law. So for the sine, you need to have a pair, so we have an angle and a side. And then you have to have one that has at least a side or an angle. So this one we can find angle P. So we're going to set it up as sine P over 10 equals, now we do the other ratio, so sine 92 over 11.8. Now we are going to cross multiply and divide. So we have 10 times the sine of 92 divided by 11.8. And because we're dealing with an angle, we have to do sine to the minus 1 of this answer. So type this into your calculator, and you should have gotten 58 degrees. Once you have two angles, to find that remaining angle, we're going to do 180 minus 92 minus 58 to be remaining with 30 degrees, 30 angles. What? Okay, so there's our sine law. Probably more difficult to remember is our cosine law. So you can tell you're going to do a cosine law when you are dealing with three sides and no angles. And remember, this is when you have no right angle, this is what you have to do. So in the cosine law we have A, and this is the simplified cosine law for an angle, a squared minus b squared minus c squared divided by negative 2bc. And all you have to remember is that this a and this side have to match. It does not matter which one is b and c as long as you do your a values to match. So let's find this angle first. So we're going to find angle B, and it's going to be cos to the minus 1 of 19.5 squared, subtract 10 squared, subtract 20 squared, so the other two sides, divided by negative 2 times 10 times 20. And to make this a little bit easier on yourself, try typing the top number in first into your calculator and the bottom number in second, and do that. So pause the video and try typing those in. So you should have got negative 119.75 and negative 400. When we type all this into our calculator, we would get 73 degrees. From here, to continue to solve the triangle, you can either do the cosine law again, or you could do the sine law. And once you have two angles, you can solve using 180, subtract the other two angles. I'm going to stop there though, because this is review. If you have any troubles with this, you can go back and look at the videos from the trigonometry unit.